Hi, everyone. Welcome to the Sunday edition of Advent of Code in Kotlin. Really delightful that all of you have decided to spend your Sunday or part of your Sunday with us today, doing a little bit of puzzling, doing a little bit of discussing, and hopefully also having, a bit of interaction. It's going to be a pretty great time. So yeah, if you're currently hanging out in the chat, make sure that you say hello and maybe already let all of us know how you felt about today's challenge. Because I have to admit, this morning when, I sleepy-eyed, small eyes, laying there reading the problem description, I was like, yeah, this one's gonna take a minute. This one looks not as easy as maybe I would have anticipated. So yeah, thank you everyone who's already saying hello. Very excited to hear how you felt about today's challenge. Already having the first people mentioning here. Yeah, I've done it in a very dirty way, but I mean, hey, usually the first draft of whatever you do, just to kind of get you there, it's a way of solving the problem, and then you can always go back and spend a little bit of time refactoring things. That's how I usually do it. Hello from France. I've also done it a little dirty. Yeah. I wonder what it actually means when you folks say dirty, because I think there's a lot of, and we can probably discuss this on stream today as well, with my wonderful guest who I'm gonna introduce in just a minute, because I think there's a lot of very different ways of how you could solve today's problem. I've taken a look into our community on Slack, and I've seen solutions that range from 15 lines of code to 150 lines of code, and very valid. Like, neither of the, they both have merit to exist. Saki says, I wrote the ugliest code of my life today, at least in Kotlin. I wrote uglier PHP in middle school. Yeah, I think if I were to revive an old hard drive or two, I might also still find a little bit of PHP code on there that I'm not entirely proud of. Yeah. Okay. But I think we've had enough time, just you and me chatting. I think it's the time we add someone to this conversation, so that it's not just me speaking into the empty room. So I'd love to introduce today's guest to all of you, and that, if you've looked into our Twitter, or if you've looked into our Slack announcements, you'll actually already know this is not going to be a big surprise. But if you haven't checked that out yet, and you just enjoyed the mystery beforehand, I would love to introduce to you Maya. I would introduce you as a Kotlin enthusiast. You're also a longtime Android developer, and you were also in the last couple of in the last couple of days a very active chatter in our live stream. Hey, Maya.
Hi, Seb. I'm super happy to be here. This is like one of the best ways to spend a Sunday evening, I think.
You think so?
Like talking about code, hanging out with friends.
I think it's always a pretty good time. I have to say, I keep on looking forward to December because I know that Advent of Code rolls around. But still, I keep forgetting how much I enjoy hanging out with people and discussing about all of this. And it's always so impressive that a problem that you solve, there is always so much to discuss about it, right? It's never a clear-cut thing where it's like, this is the correct solution and that's it. There's always so many different approaches. It's not your first,
and if I look back at the history of the Advent of Codes that I've done, I can just see how I get better and I get quicker. And yet I must judge how much time I'm going to spend on it every single year. I think it's going to be December, not a lot of work. It's almost holidays. I'm just going to do the Advent of Code. And then it just swallows like a whole section of my day.
Yeah. That's kind of how it goes for me as well. But I'm always just really, really looking forward to it. And I do think that our community is similarly enthusiastic for it, because it is a great way to learn something new, to hone your skills, and as you kind of progress through the levels, to really put yourself up to a new challenge. Have a couple of people here already mentioning you. There's a greeting here as well from Marton saying, "Great to see you on the stream, Maya. Thanks for being active in chat all the time, including on the Twitch streams." Because you're definitely making it a lot more lively when we're out on Twitch, just hacking away at things. So it's really delightful to have you here as well.
Yeah, it's my pleasure.
We have a couple of other already interesting points here that I'm just going to save, and I'll bring these up later as we discuss the actual the topic that'll go on. But I do want to do just the tiniest bit of housekeeping, because there is some elves in the background who did nudge me a little bit to mention a couple of things. Now, of course, we've already mentioned the blog post a couple of times about our Advent of Code 2023 campaign, which allows you to win prizes. And one of the points that's actually really important about this is you don't have to be the very first, and you also didn't have to sign up from the very beginning. If you're watching this right now and you haven't signed up yet for our Advent of Code leaderboards, or you haven't yet created your repository on GitHub, it's still time. You can still do that, because we're not rewarding the people who have the top scores and who do everything the fastest way, because it's a learning opportunity for you folks. So as long as you sign up and you solve a couple of tasks, there is a chance that you'll win some exclusive Advent of Code in Kotlin swag. And of course, if you want to learn a little bit more about how you could solve Advent of Code in Kotlin, you can go back and take a look at all the resources here. And this actually isn't your first time on our streams either, right, Maya? You were here last year for AOC. Is that a good memory for you?
Oh, it was lovely. It was the elves that got their backpacks muddled. I think they were doing backpack compartmentalization, if I remember correctly. So that was fun memories.
Yeah, there's always a lot of cool stories happening in the context of Advent of Code, and I think we'll have a lot of interesting stories today as well. So I think, actually, without further ado, my call to action has been done. Make sure you sign up and don't miss this opportunity. But I think we can just dive straight into our dramatic reading portion of the evening, and once we've done that, we can move on and see a couple of solutions. So don't worry. I know you're here to hold me accountable. So obviously I have the hat. Gotta make sure I put that on. Still,
I don't know what I would have done if you didn't have the hat, right? Would I have scolded you?
I think you would have. I think so. At least, mentioning that you... I think it's okay to be disappointed when the hat's not there. I think that's a very valid emotional reaction, and I would not deny you that. Great. Wonderful. So, without further ado, let's have a look into day 3, gear ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. there are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here's an engine schematic. In this schematic, the two numbers that are not part numbers, because they are not adjacent to a symbol, are 114, top right, and 58, middle right. Every other number is adjacent to a symbol and is a part number. Their sum is 4,361. Of course, the actual engine schematic is much larger. What is the sum of all of the part numbers in the engine schematic? And we can also open this one up so that you can see how big that actual engine schematic really is. Wonderful. So Maya, what were your thoughts when you read this challenge today?
Well, I thought that they'd given us some clues in the previous one, right? So there was like looking for digits. We had the digits before. So there was going to be some kind of parsing. But I also know that if I look at a previous solution, sometimes it leads me down the wrong track. And the other thing that I learned quite quickly about Advent of Code is I just put the real data up on screen, and I kind of just stare at it and let it kind of like filter into my visual cortex for a bit to try and see if I spot any patterns or if I can get an idea. So both the test data and the real data. And so the thing that I noticed was, I know we've had puzzles before where you were looking for little adjacent you're looking for blocks adjacent, but for this particular one, I was thinking that you could, when comparing, you could compare two rows at a time. So that idea of comparing two rows at a time started filtering through my brain when I was looking at the big piece of data. And so I thought, windowed, of course, we haven't used windowed before. Maybe I'll see if I can do it with windowed. The other thing that I did notice was that it does feel like a big schematic, but it's actually not that much data. I mean, it's just like, I think it's 150 lines of things to pass. And so early on, I can have the luxury of building a beautiful data structure that's got all the information that I want inside the big, beautiful data structure, and not have to worry about optimization or running out of time. Because, it's day 3. They're not going to hit us now with such an optimization one. So the first thing I did was then create the data structure and then started breaking down the puzzle into sort of the steps that I think I would take.
Okay. All right. Do you want to directly jump into your code for that one?
We can.
That's a good idea. I'll have to admit, when I saw this one, my initial thought was, yeah, this is going to take a moment. This is not just going to be like, I didn't have this. Sometimes there are problems that really lend themselves to being solved with the Kotlin standard library, where it's just like like you said, you'll do a windowed or you'll do something like this. You'll do a small transformation or maybe a little bit of matching, and then you get things. But then I realized that, well, there's a whole lot of like indexing, and actually as one of our viewers has already mentioned, we're looking at 2D grids here on the second day, which means we got to start handling coordinates, probably some X and Y stuff, or column and row, depending on what fits your mental model, and you kind of gotta go from there. I'm personally not a super big fan of those because it usually means I'll get lost in the woods with finding out how to organize those in memory in the first place. But I mean, I was like, okay, well, that's a challenge. It's certainly a good way to wake up. So just like yesterday, when we looked at the solution together with Artyom, and we're taking a look at Amper as well, we're in Fleet again today. And we have a look at your solution here. I'll make sure that I'll follow you here, and you can kind of drive a little bit of a walkthrough of your solution here.
Okay, so the interesting thing for me with these solutions are that some parts of the problem, my brain automatically thinks in standard library chaining functional style. And some parts of the solutions, my brain just automatically thinks objects, or sometimes it thinks imperative. So it kind of like jumps into those kind of modes. Sometimes if I have time, I'll rewrite and see if I can switch it to the other. But what I said about making a beautiful data structure that I can understand and that everything makes sense, also because I don't know what part 2 is going to be. And if he's got more than one symbol, I was figuring he needed more part 2. So I'm going to scroll to the bottom. So the first thing I did was I made these data classes. I had a sealed class with a number and a symbol. It's a number, not a part, because not all the numbers are parts, right? So, and then I stored some information in there. Like for the number, I had the actual value, because that'll help me later to add them up. I had the range of the number initially, and the row. And then for number, I have this named capital letter function, which is a constructor. You'll see where we use this, and symbol. And then I also had, while I was in number later, as I was solving the problem, I have these 2 other variables inside number, which is like the expanded range. So this row is the row that it's on, and the X range is the X and the Y, how far the number is in the grid.
I'm very sorry, but I have to say I really like this one. That's a really cool approach. We'll go back into my solution later. I'm just sorry, I couldn't contain myself. That's
okay,
really
but now what I want to say to chat. So chat, if you see something that you think can be different or improved, please tell me, because this is a learning experience for me, so we can see this as a code review. And the other thing is that my solution worked perfectly on the test data. As I saw in chat, some people said that as well. It did not work on the real data for 2 faults. Yeah, I had 2 faults. I had an off by 1, and I had another fault. So if you can see the mistakes ahead of time, I'll point them out when I get there. If you can see the mistakes ahead of time, shout and chat if you can see the mistake that I had, and then we can see if you can catch it just from code reviewing my code. So I have these elements, and then if I just scroll to the top, usually in the morning, I have to write the code so that it sounds like the story. So it's like, get the engine schematic by extracting the elements. Take the engine schematic, find the parts, obviously, get a sum of the values. Okay, this is too long. It's just because I always return things in longs just from an old history of Advent of Code. So that looks like it's easy, right? We just have to do 2 things. We've got to extract the elements, and then we've got to find the parts, okay? Okay. So let's go to extract the elements. So what I'm doing here is I've got a function. I'm taking in a single row. So this is row by row. It's pulling through the elements. And for this particular part, my brain automatically jumped into imperative code. It didn't, because it was like I have to look forward and I have to look back. The imperative way of just looping through each single character was the easiest way to understand this. And so,
can you make sure that you click your cursor there so that we can see? Thank you very much.
Oh, okay.
Okay.
Cursor. Yeah. So there's the state, there's the index where the number starts, and there's the current number, which is a blank. And then I literally loop through every single character one by one. And then there's transition spots. If it's a number here, if it's a digit, then I just append. And if the start index wasn't set, I set the start index to wherever we are now, because we've got an indexed for loop. The other condition is either it's a dot or a symbol. So when it hits a dot or a symbol, it's a transition towards the end of a number. So then I've got to do something. If it's a dot, if it's not a dot, like if it's a dot, you don't do anything. If it's not a dot, then you create one of these symbol objects and you add that to the list. You've got the value of it, you've got the index, and you've got the row. And then at every transition, whether it's a dot or not a dot, you need to now get the number. So I'm checking if the current number is not empty, because you might have had a dot and a dot and a dot. If the current number is not empty, it's the end of a number, in which case I add that number to my list using that number with number start and the end of the number and the row. Now, initially, because I thought the way the sorting would work, I would use windowed. I didn't have this row variable, okay? So remember that, because I added the row window. Yes, you can use windowed, and I did use windowed, but I initially didn't have this row variable in my data structure, but I added it later. The other thing that I didn't have is the first loop round. This is like at the end. If you're at the end of the row and you've finished looping through all of these, then maybe you're still in the middle of the number, but you didn't finish the number. Now, so this is my first off by one error, because this piece of code, I didn't have this in. And so if you look at the test data, I can't see if we can see the test data, but the test data doesn't have a number that sits onto the edge. There's always a dot at the edge. Now, the real data has numbers that are sitting right at the edge that doesn't have a dot at the end. And so if you do that, then you won't catch the last number, so you'll be missing numbers. Now, there's two ways to solve this. You could either do this, add this extra little snippet of code there, or you can take the input data and just drop a lot of dots on the end. Then it would have worked as well.
Uh-huh.
So I think, depending on how the rest of chat also solved the problem, this might have caught them because the test data doesn't have this in it.
Yeah, I think with the slight delay, Zelt actually mentions this. What happens when the number is in the last row? Won't it patch it together with a number of the next row? And I guess that's exactly the call that you just made.
Well, not with the next row, because this extract elements runs only on the string. It goes row by row.
Good point.
So it won't catch the next row, but it will miss the last one. If you don't have this snippet of code over here, it'll miss the last one. So that was my first error. Okay, so now I have a data structure which consists of a list of these schematic rows. I have a type alias here for it. It's just a list of elements. I have this type alias because otherwise I see list of elements, which can be confusing. It's easier for me to just see list of the schematic row. That. So that's this part here. So at this point now, I've got an engine schematic, and I can do anything with that engine schematic now, no matter what happens, even in the next part. And so the next thing I have is this find parts. Seb, if you see things that you think I should be making better, you can jump in and interrupt me.
Absolutely not. I thought it was very funny that you said, like, I have a data structure that'll represent whatever whatever they'll throw at me, potentially also in part 2. And I think that's if I've learned anything from my advent of code, it's that Eric is very good at entirely reinterpreting the input data in a way where whatever data structure you've chosen might just still fall apart.
Might fall apart. But in the early days like this, I can build this luxurious data structure with lots of objects that have all the information inside it. So now, the find part section, right? So the first thing here is we return a set. First, I returned a list. And if you don't return a set and you return a list, you'll get duplicates because it'll look and find a part in 2 different places and make duplicates. So I had a set there. There's the parts, a mutable set of numbers. And then here's the windowed. So I window over 2. So what that does is it takes the first row and the second row, and it finds all the parts by looking at those 2 rows. And then it'll take the second row and the third row and find the parts. And that's why, because it's windowing like that, you need the set to make sure that they are unique when you put them in. And so here I get the symbols out by taking those 2 rows, flattening them, and filtering by symbol. So the flattening, you don't need to separate out now which one's above and which one's at the bottom. You can just flatten all of them because we're just going to be comparing the fact that it's 2 rows. We're already comparing the y coordinates, and we're flattening, and now we're just comparing x coordinates across all of them. So whether it's something that's adjacent above or adjacent in the same row, you'll catch them both by doing this. So I've got the symbols, I've got the numbers. I take the numbers and I filter, and I look if there's any of where the symbol column is in the range, but not the range of the number, the expanded range. So the expanded range is a -1 and a +1 of the range of that number, or expanded column. I'm looking if the symbol column is in the expanded range of the numbers columns. And then I just add it to my set, and then there it is. Now, My other fault that I had here was because I was using Windows. Initially, let's just go to these data structures. I didn't have this in here. I didn't have that row in here because I'm thinking, right, I'm windowing, I'm sorting the X stuff out. It's cool. I'm just going to find them. I don't have to worry about the row position. However, the test data was fine, but not the big data. And it took me like, I don't know, half an hour to figure this out. At one point, my partner said to me, why don't you just rewrite it in a different algorithm and then see if it works then? I said, no, what do you mean rewrite it in a different algorithm? So to test things, I counted how many symbol characters there were in the table, and I counted how many symbol objects I had in my table, my new beautiful data structure, and they were the same. So I knew I was getting all of the symbols. So it wasn't like, and if I'm getting the symbols, I'm probably getting the right numbers as well. Then I spot checked the numbers during that thing. And then the secret of it was, so all of that looked right. There was nothing there that I could see that was wrong. So the interesting thing is that this is a data class, right? Yep. And a data class has an equals method. And the equals method of a data class will compare the values. And if you don't say what row it is, if there's another part in a different place on exactly the same index and exactly the same number, you're going to miss it. Because it's a set.
Yeah, okay, because you're just... Okay, because these are, as far as Kotlin is considered, by value, they are equivalent.
Yes.
Huh.
What I could have done is, I could have gone and done that. I think it's the 3 equals to make sure it's the same object.
Yeah.
I could have used that. But set doesn't work with 3 equals. Set uses equals.
Mm-hmm.
So I added the row. And just by adding the row, of course, the 2 numbers become unique again. And then it worked.
That does sound like quite an odyssey, to be honest. Yeah, I think it was a good instinct to add an actual differentiator to the number rather than like trying to rely on some internal behavior or of referential equality rather than value equality.
Yeah.
Also, but as a note, if you really would have needed this, I guess while you couldn't use set, what you could do is distinct by, and then provide like have a comparator that compares by reference instead of value. So you could do that. I would very much not recommend it.
So the reason I didn't do that was because I didn't know what they were going to ask me in part 2. Now, did I?
Very, very good point.
So I thought, well, let me just expand my data structure just a little bit. It can just store a row as well.
Yeah. And I mean, who knows? Maybe that information will come in useful. Awesome. So we can, I guess we can run your first part, and we'll see some hopefully successful output here. So I'll just do that real quick, and we'll see that. Okay, little spoilers here for the second part, but it does pass the first one with the test data as well as with the actual input for my puzzle, so my puzzle input. And I have to say, Maya, great work on this custom output. I mean, there's a whole different type of feeling of success when you run it like this rather than just having the plain number, I gotta say.
Thank you. Okay, what do you want me to do? Do you want me to do the second half, or would you want to show us your first half, or how do we want to run this?
I think what we'll do is we'll continue through, because we've already seen that you've also solved the same the second part of the puzzle. Also, I'm sure people really want to see the hat again. And while we're still in the context, we'll see how your data structure that you've prepared fares with part 2. So the engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong? Fortunately, the gondola has a phone labeled "Help," so you pick it up, and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers, or asterisk, I should say. Its gear ratio is the result of multiplying those 2 numbers together. This time, you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. So, considering the same engine schematic again, in this schematic, there are 2 gears. The first is in the top left. It has part numbers 4, 6, 7, and 3, 5. So its gear ratio is 16,345. The second gear is in the lower right. Its gear ratio is 451,490. The asterisk adjacent to 617 is not a gear because it is only adjacent to 1 part number. Adding up all of the gear ratios produces 467,835. What is the sum of all the gear ratios in your engine schematic? Okay, again, just from my personal assessment of that situation, I was like, great, did I code myself into a corner here? I wonder if whatever I build will hold up to this test of time. Yeah. How was it for you?
Yeah, so I was super happy with my beautiful data structure with all my objects in it, with my rows and my ranges, because I knew that I'd be able to like just do some. Then I could you start using the standard library filtering and collection handling utilities now, because I've already built up the data structure. And can you open the run window again briefly, Seb? There's an interesting thing there to see.
Yes, we'll rerun this.
Okay,
yep.
So if you look at the timestamps there, you'll see that my big one, I don't know why for the second one, it takes the first one and the second one takes less. But if you look at the timestamps of the number 1 solution and the number 2 solution, they take about the same time. Not necessarily the most efficient thing, but they're doing similar work. The second one's just taking slightly more work. Okay, so we can jump into the code now. You can close that now. All right, let's see. Okay, so now by this time I've got all of my data structures set up like that, and my extract parts or extract elements function we've gone through. So that I'm going to close because we don't need to read that anymore, because that didn't change at all. I could use it completely as is. So part 2 is, again, get the engine schematic by extracting the elements exactly the same way as part 1. And then the solution is just take the engine schematic. Now I can flatten this whole thing. I don't need to work on it on a row by row by row, because I've got that row variable in my data structure now. So I didn't use windowed for this one. Then find the gear parts and then sum them. I return the gear parts as a pair of ints, the values of the gears of the parts that are around a gear. So I return a pair of the values of the parts so that I can multiply them and return them. And so the crux of what I had to solve was just find gear parts, because all of this, extract elements and all of the others, I could reuse from part 1. So I'm going to close find parts, and I'm just going to open find gear parts. And so here I have a list of all the parts. I've got a list of all the potential gears. And the way that you know something is a potential gear is if it's a star, but they're not necessarily all gears. We still have to test them. So I've got a list of where the stars are, and I've got a list of where the parts are. And because they're data structures, they know their data classes, they know what their ranges are, and they know where they are. So they've got all the information you need. And then it's a question of mapping through each of the potential gears and then filtering the parts that are next door to them. And this you do by checking that the row is in the expanded row. So that's arranged above and beyond. And the column is in the expanded column. So at the end of this map, we have all the parts that are next to asterisks. But that doesn't mean they're a gear yet either. They need to have exactly 2 parts. And so then it's just a question of filtering, because you're getting a list here of numbers, filter by 2. And then this map is just to get it into the right format so that I've got the values as a pair. And then multiplying and getting the answer.
I have to. I mean, this is one of the very nice things about your code. I think is that it does read exactly like kind of the story that you would have in your head. And I think, and when we'll look into my solution, we'll see that I do this in a slightly more complicated way. The idea of introducing an expanded row and an expanded column, just defined as int ranges, which you can use things like, hey, if I already have a range, I can just take the first and the last element, and I could just like go -1 and +1 in both directions. That's great. Like, this is really awesome. And I think the big power here is like, if you're already working with ranges, is it's much harder to do off by 1 errors than if you are just working with like lengths of strings and all of that. Because for me, if I have an offset and I want to position myself after the offset plus the length of a string, do I still need to add +1? Or was that the last index of the string? Like, that's always, it's just something that I have to keep in mind. And yeah, it's a little difficult. But yeah, there's yeah, go ahead.
The X and the Y's, right? Like if I'm working, I've done that before where I've built grids with X and Y's. I always get the rows and the columns and the X and the Y's muddled. I always get the 4s after. I stopped using X and Y at one point because I'd always get an X muddled with a Y. So I started using I's and J's, and then I started using actually rows and columns, because otherwise I get really, really confused about which ones.
Yeah. And here, Saki says, just wrote an int range expand function, which I suppose does something very, very similar here. So yeah, I think there's a lot of people here who've done quite a similar approach. I also do wanna mention what I do like here. Rob mentioned in the beginning that when they saw the input, it was like, there's a lot of weird different symbols, but with no point for them being different. That might be suspicious. It might have already shown us what the difference is. I personally genuinely thought maybe they'll just have that for flavor. Maybe they'll just, just making it slightly fancy. But yeah. I also, we'll switch over to my solution here, and you'll see that I also tried to kind of tell a similar story, but I approached some parts a little bit different, and I think there's an interesting comparison here. So, first of all, I decided, okay, what do I have? Well, let's ignore the numbers for now. The easy part that I can always parse is symbols, like any kind of gear icons or anything else. So I essentially just decided, okay, let's just put all my symbols into a data structure to get started. And I used to do this thing where I tried to figure out the most efficient data structure, like from the get-go. Like, I was like, let's put it in a map, or even better, like, let's pre-allocate an array of the size of the rectangular playing field, and then we'll do like we'll create an operator function get with like an offset, and we'll multiply the offsets manually. And of course, because it's like, I haven't had my coffee yet when I usually solve these problems. I have an off by 1 error or something else, and then I'll spend some useless time debugging. As you said, on day 3, it doesn't matter. Like, literally, you can just put all your things into a list and like linear search, you'll be fine. It's okay. So that's exactly what I did here. What I always try to do when I have the chance is I'll try to minimize mutability, like from the get-go. So you'll see that while I create a mutable list, essentially in here, I use the build list constructor function so that the mutable list is only exposed during the actual construction phase. Afterwards, it's just a read-only list of symbols, because I know it's not going to change. or at least, well, that was my assumption. Who knows? I mean, Eric, for all I know, might have said in part 2, the part number describes the offset of how far you shift the gear in the table. And then, of course, I would have coded myself into the corner. But that wasn't the case here. So, and then I decided, okay, well, we gotta do something here to actually get the part numbers, right? So, like, what are the actual part numbers? And for that, we first need to extract some numbers, which you did using some very cool parsing logic. But I decided I'll probably just slap a regex at it, which actually worked quite nicely. We'll ignore the symbol associated numbers for now, because that's for part 2. My code is a little intertwined here. But then I just have this big loop, which goes through each. This essentially just goes through each line, but thanks to the power of Kotlin standard library, I can just say I'd like to have both the actual line contents and the index of that line, and that's going to help me because everything, like every number that I have, I'll place into a. We'll have a quick look here. I think I have that data structure somewhere down here. I'll need the coordinates because of the way that I compute kind of the surrounding numbers. Doesn't matter yet. So far, we'll just do the thing that regex allows me to do, which just tell me all the like start locations and offsets. The start location and offsets for all the numbers here. And I do have someone here in chat saying, couldn't you just have used for each indexed? And the answer for that is absolutely, you can 100%. It's like equivalent. Generally, if I don't have like longer call chains, I tend to prefer just regular old for loops. In this case, it's not necessarily nicer. It's the exact same part.
Yeah. So what I would say there, Seb, is that if I'm in like a imperative mode, then I use straight for loops. If I'm in a chaining functional mode, then I for each.
Yes, and if you actually, in fact, if you look into the, I think Kotlin coding conventions or the style guide, that's quite literally what it says. Like if you're just working on collections, prefer for loops. If you're chaining stuff, then for each is the perfect solution. Of course, there's a little bit of taste coming in here. Well, so I decided, okay, for this number, which I'm not sure yet whether it's a part number or not, it's just a number, I need the coordinate. And for that, I just need to have a data structure that places it somewhere in the grid and tells me how long it is. I personally like your idea even better of just saying, I'll tell you the y coordinate, like which line it is in, and then you'll just give me a range. That's actually a nicer way, because the way that I did it, I need to start juggling. Like, I need to start reconstructing information that I already had, which was the range and the length. I need to start reconstructing that later in the code. And that's actually kind of what bit me here. But I decided, like, on a high level, what I wanted to have was just for this number coordinate, I just like to have all the surrounding coordinates, right? Like, that's just kind of the hull around it. Now, my code for this is, because, again, this was morning code, was quite verbose, actually. I was just like, okay, we'll just write this out. We'll say we have a couple of coordinates that are above, which is just, we'll go one line above, and we'll just fill everything out from x minus 1 to x plus length plus 1 question mark, because that was actually the issue that I had in the morning, because I was like, okay, we need to go like all around, so we need to make it a little longer. No, of course, since it's length and not last index, just like that. And then we'll do the same for below coordinates. These are actually, like, these loops do the exact same thing. So I could just move this part in here. Like, there's no other structure for it. I just had that in there. So I think I probably broke my code now. There we go. So we just have those above and below, and then we have the before coordinate and the after coordinate. And because Kotlin just allows you to override the plus symbol, or because the plus symbol is overridden both for like multiple lists, but also just for vectors, that works perfectly fine. Or for primitive types, that works perfectly fine, and I can condense this. This is not very efficient. Like 100% it's not. There's a couple of things in here, but I wasn't really concerned with efficiency. I just wanted to have something that I can quickly explain to myself in my head, and then hopefully to you folks. So, with that in mind, I decided, okay, I want to know for each number, does it have a symbol adjacent to it? And now this becomes like a pretty straightforward way, because I collected the symbols way before, so I'll just say, give me all the symbols where its location is in the surroundings. I maybe should also mention that I stored like locations and stuff in a vector2 class. It barely is required to explain this because it just stores an X and a Y coordinate. Yeah, so at that point I have all the adjacent symbols. I can parse out the number. And then what I can just do is I can add it to the to my adjacent. So if there is something in here, then I'll make sure that I'll add the number to my parts numbers. So that'll just be another element in here. And then at the end of that whole story, that's pretty much it. You just take all the part numbers that you've just calculated this way by just figuring out whether they have a symbol next to them, and you sum it up. There's no big change here from your code. I did go a little crazy with trying to maintain as much immutability as possible to get part 2 done, because what my initial thought was, maybe it's okay if I just go into like the symbols, right? Like into that class. Maybe I'll just add like a mutable field where I can, whenever I see a number associated with a gear, maybe I'll just be able to attach it here, and then I'll figure it out at the end. And of course that works, but it's not a good idea. Like data classes, naturally, you've figured out the part with the equals part of it, where of course it takes all the fields that are in here and uses it for equality. I feel like probably at some point I may have figured out the hash code part of this story, which is if you have a mutable field in here and you change the values of a data class, then its hash code is going to change. So you can no longer use it as a key in a map because it doesn't have a stable hash code. So that's I think a good point to keep in mind. So what I thought, like what we can instead do is we'll just keep track of all the symbol associated numbers. So this is kind of like it's the inverse relationship. It's whenever we see a symbol, like whenever we see a symbol like in the like surrounding area, then we'll just add a pair. In this case, it's just a type safe pair, but it really is just a pair of a symbol to that specific number. And then when you do that, you finally have all the information that you need, and you can massage this a little bit to arrive at the final result. This is a little tricky, so I'll walk through this part step by step as well. And I'm sure, and I would really love to hear a couple of opinions, both on my approach and maybe also on Maya's approach, just to kind of see, is there a way that you prefer? Is there something that feels more natural to you? Happy to discuss. So again, keep in mind the symbol associated numbers is just a list of all numbers close to whatever symbols they're next to. So first of all, just like Maya, I get rid of everything that's not next to a gear. Like any like relationship that's not with a gear, I don't care about. Then I figure out, then I use group by to create a map. And that map is from symbol to a specific number, right? So now we get essentially the mapping. We'll have a single gear, and then if that has 1 or 2 or 5 different numbers associated with it, we'll get all of those grouped under the same key. We don't actually care about the key. The only part we care about is like the number of things in that list. And because the requirement was that we get 2, I'll just do a filter on 2 of those elements. Then I figured at this point, I'm already this far down the functional programming rabbit hole that taking two numbers and multiplying them is already that's already too basic. So instead, I'll map out the amount and I'll reduce it using int times. So this whole code is just a very crazy version of just taking hits 0 dot amount times hits 1 dot amount. Please don't write the code that I wrote here. I just thought it was fun. Either way works, though. These are functionally equivalent. This one could also handle if the hit size was 3 or 5 or anything like that. But of course, simpler code is usually better. And then at the very end, all you do is you sum it up like you were requested to. And that's it. I have to say, explaining this code, I realize it's very dense. There's a lot going on here. So, when you were explaining it to me, there was at one point I thought, how are you going to... Okay, the stuff that associated number list, that data structure with the symbol associated numbers, that symbol, it's an object, right? So it's like there's a star symbol, and so the keys are unique, right? It's not the symbol like just the star. Yeah, no. So this is the symbol is an individually keyed element in the whole thing. So because of the hash, right? Because of the hash of the data class. Yes. So if in another way of thinking about it, if all of this was IKEA instruction drawings where you have little lines going from the symbol to the part number, this data structure just stores all the lines. It just stores all the relationships between this points to this symbol is pointed to by that number, and then it allows me to kind of do all this other stuff. Yeah. Okay. So that's how you get it. That it has all of them, but doesn't have duplicates. Yeah. So this is kind of one of the big tricks. The other big trick that I did have was because I actually used the easiest data structure possible, which was just a list of vectors to store everything, is that you'll notice that my coordinates, it doesn't do any coercing. It doesn't limit anything to the playing field. This actually generates invalid coordinates as well. But the whole point is just that since I'm just searching a set of those at the very end, if there's a coordinate with -1, I'll never query that. I'll never ask, is there a symbol at -1? That doesn't happen. So this is actually something this code was much longer when I initially wrote it. I was like, okay, I'll make sure it's always constrained, and we'll keep it nice and tight. And I was like, wait, does it even matter with the structure that I have? And the answer is it doesn't. Yeah. Because I didn't use the ranges. Some of my ranges are also off it's also -1 because the one on the edge and is bigger than the data structure, and they're okay because as long as the testing if something else is within range works, it's fine. Yeah, for me, this is just a matter of, or it's one of the reasons why I shy away from going directly to to two-dimensional maps, because when you have a two-dimensional map and you have negative stuff, immediately stuff starts getting quite wonky. You're getting index out of range exceptions, and working around those or trying to make those a little nicer is always or can always be difficult. So I decided I'd kind of keep it quite simple here. I have to what I found a little interesting actually was I looked at my code and I scrolled to the very bottom and I saw 95 lines, and then I'm actually not sure how long your code is. Yeah, your code is well, okay. We'll ignore the main method, but the related stuff for the day, it's also 100 lines of code. And then I looked into the Kotlin Lang Slack, and I saw other people solving both parts in 12 or 13 lines of code. And for a second, I felt bad, but then I realized there's actually no reason to feel bad. Those are just they're optimizing for two entirely different metrics. Yeah, really. So
So what time zone are they in, I would ask?
That's a good
That
question.
would be my first question. And then the other thing I was wondering about, we have benchmarks to see the time, how long things take. Do you know of tools that can say how much memory you use? Because that would be the other thing, because you're either optimizing for time or optimizing for memory usage. Like, what tools are there available, and can you get them in Fleet, or do you have to run them elsewhere?
That's actually a good question. I have to admit, I have not done any JVM memory profiling. And if you will look at my code, I will say, by the way, you say you can either optimize for memory or for time. I'm optimizing for neither. I'm generally the part I'm optimizing for is I'd like to have code that I can explain to you and that you hopefully get an intuition for. Like, that's generally like what I do. Because if you look at it, right? Example, performance optimization. Let's look at how I implement surrounding coordinates. I'm allocating like 2 temporary lists here. Those go on the heap, so that takes a bunch of time and a bunch of memory. For every single vector element, I allocate a vec2 like wrapper function, rather than, I don't know, doing the crazy thing that, for example, Android or Compose does and packing those into the same value or trying to keep them on the stack somehow. Each of these plus operations, as far as I know, also allocates an additional intermediate list. And then I've also decided that doing all of this, just because it's nice, I'll define it as an extension on number coordinate rather than being a member, which means this gets recomputed every time you access surrounding coordinates. You could, of course, just stuff this into number coordinates or numcord as a member and just say, because number coordinate, quick reminder, that's just a data class with fields that never change. So you know that you only need to compute this once per number. But that was all an optimization where I was like, I only use this once. Like, it's fine for here. It's not fine for everywhere. I wouldn't write this code if I knew this wasn't like a hot loop or performance critical. But to just be able to say, give me the surrounding coordinates and I can explain to you, or you can look at it and you'll see, okay, all he does is like run a line above, run a line below, and then put 2 elements at the side. That intuition for me is more worth than having my solution run 20 milliseconds faster.
So I guess it's a completely different optimization. We're optimizing for mental health. That's what we're doing.
Pretty much.
This code is optimized for self-care and mental health optimization.
And a little bit of teachability in this case as well, I think. Is it still ON? The underlying algorithm actually doesn't change, so there's nothing. There's no performance issues there. We're just talking about the theoretical hard performance constraints that you might have. Yeah. Jonathan says 2D map you can represent with vector 2 to whatever you want to store. Then x is -1 is not a problem. You're absolutely correct. That's very valid. Maps don't lend themselves to changing the keys though. And again, when I first approach these problems, I'm always like, I gotta be ready for everything. Like, I gotta be ready. If push comes to shove, I'll turn that vector 2 into 2 vars. If someone's telling me you got to do some offsets, the first thing I'm going to do is I'll turn it into vars and I'll write a bunch of mutable code to validate my idea, and then I'll clean it up afterwards. But that's one of the reasons why I choose sometimes the silliest data structures like possible in this case. You don't have to. If you like the other approach better, you can. Marino says, hi, started watching a bit late. Here's an idea of how to represent the grid. Map from point to chart. Yeah, I think that's essentially the same way. Yeah, that way you can always check the next point, and if it's not the grid inside the grid, it'll just be null. Yeah, so I guess that's kind of the same thing that Jonathan also said. Yeah. Andy asks, I joined the Kotlin Slack. Can you tell me which channel is for Advent of Code? It's the channel called Advent of Code. Hopefully you'll find it if you look into the directory. So it should be just a very, probably if you just look into the directory, it should be at the very, very top. Yeah. So I really have to say, Maya, I'm still not over this. I really like the way that you handled these ranges, and I've definitely like learned something new here, because I actually didn't realize that on a range I could just do like last. That's actually very nice. For some reason that just escaped myself this morning.
Thank you. Yeah. I must say I had a lot of fun today. I mean, even though I thought it was quite challenging for a day 3, maybe it was just because yesterday was relatively easy. Today, but I mean, it felt like a relaxing Sunday morning.
I'm glad. I have to say, for me, so the initial problem that I had was having just an off by 1 error, and as usual, off by 1 error that doesn't reproduce in the test data, and interesting enough, it was an entirely different one from yours. For some reason, I just generated for 3 lines. Sorry, I think I have a small visualization here. Because of that off by 1 error, instead of generating 12, so 5, like for a 3-digit number, instead of creating 5 at the bottom, 5 at the top, and then 2 on the sides, I created 14 surrounding coordinates, which I think I just accidentally duplicated these 2 at the end. And of course, like for some weird reason, the test case did not manage to cover those, but then with the actual test, it stopped working. And I had all kinds of wild theories. I was like, wait, he says symbol. Is a number a symbol now? And you get a different result when you do that. But it's also not the correct. It's also not the correct result because numbers aren't symbols. But it was. I was a little nervous. I was like, what am I missing here? But I then inspiration struck. And I was like, let me check how many coordinates I actually generate. So sometimes.
So I was thinking that if I didn't get the answers for tonight, we'd just have to get chat to help us debug, right?
I think
like
that
what would I have done if I got here and I didn't have any of the answers yet? I just had a fault. We would just have had to have a fault finding session. It would be fascinating because then we could see how to debug in Fleet, which is actually pretty cool. Oh, I found a cool thing. I know if you click the run button. At the top.
You can actually do this yourself, by the way, in theory as well.
Okay.
But yes.
I wonder if there's a pop-up. Okay, we go here. I'll show you. If you go, say for instance, you're clicking on the run here. Where's the main class? Where's main?
Yeah. So if you want to see the pop-up, then I guess it's better for me to do it. Yeah.
Okay. So I had a problem where if you click run, it says you can either run or debug, right? So now click run. Okay. Now, no, don't click run again. Now look at the bottom there, in the bottom terminal window.
Yes.
There's a little reload button on the right. And that one will do whatever the last one was you chose. If you chose run, it'll just do run again. But if you're busy debugging, then it'll do debug.
Very nice. Very elegant.
So I was very pleased to discover that feature this morning. Because otherwise it's always like click drop down, click drop down, click drop down, which was like 2 clicks instead of 1, right? So thank you, Fleet team, for making a little button in the corner.
So this is actually, by the way, this might actually be interesting for people also to know. Do I hear correctly that you also chose to present in Fleet today because you are solving the problems in Fleet like every day?
Yeah, so I'm doing all of this. I'm doing in Fleet. So I've have a sort of an interesting history of IDEs. Of course, I use Android Studio for my day job, doing Android code. But at night, I mess around in KMP, and I used to do that in the IntelliJ IDE. But then it became not so efficient to do it in IntelliJ because the plugins weren't happy. So I moved back to Android Studio for that. But as soon as you could start doing KMP stuff in Fleet, I started doing Fleet because Fleet because I was trying Fleet out on the side all along. And this year's the first year that I'm doing Advent of Code in Fleet and not in IntelliJ.
Okay. And
I don't know, my gut feeling is that maybe the code with me, it's just sort of lighter, and the interactive mode with 2 people on the same one seems less glitchy. Because when I was testing that with IntelliJ and with Android Studio before, I had issues with that, which I haven't had with Fleet.
Okay. Yeah, I mean, we've together with Martin, we've been doing a lot of fleet development together on our live streams as well, and we've found it quite pleasant to work with, and of course with the added Kotlin and Kotlin multi-platform support in fleet, it's become a bit more of a breeze working on projects like these. But that's really awesome.
Yeah, and the AMPA conversion I did just before Advent of Code started as well, because with Advent of Code, because it's really just a simple project, right? Like you don't need all of the things. It's really collapsing the whole tree of packages is much more pleasant to work with.
Oh yeah. Now, and of course, I mean, as we've seen yesterday, Advent of Code, as usual, not only in the problems but also in the surroundings, it lends itself towards like learning and trying something new, or trying a setup that you may have not tried before. So Amper is a great combination. Fleet's a great thing to try out, which I think is quite delightful that you're also taking that chance to do that, because it's not every day you just get to try completely new tech stacks, right?
Yeah, I'm just curious about shiny new things, right?
Yeah, I'm in the very same boat here. Whenever there's a new thing I can get my hands on, it's always a delight to give it a try. And Andy here also says happy to start using Fleet as well. It's quite exciting. Delightful. So we're about to wrap up here, but I do remember that before we started streaming, you did mention that you wanted to shout out a specific solution for today's problem. Would you like to introduce that one?
Yeah, so on the Advent of Code Reddit, they have these wacky solutions, and I saw today someone that solved both parts 1 and 2 in Vim keystrokes.
So, quick flashbang warning, I guess, because Reddit is in light mode here, but I'll open this up, so just shield your eyes potentially. And we have that one right here. Yeah.
So, some of it I can understand, but I think the really curious thing that this person did was he had a way of changing characters and making the numbers uppercase to tag which of the parts were actually real parts.
Okay.
So he changed the numbers 0 to 9 to letters so that he could make them be uppercase, and that's how he marked which of the numbers were actually parts.
That's incredible. That is very incredible.
Really, I mean, you could probably code that up in Kotlin as well. You don't need it.
Yeah.
That's
Actually,
how he did that.
Yeah, I was talking to a colleague earlier today who was also solving this problem, and he also took the approach of rather than just parsing everything into a data structure and then like doing a bunch of manipulations on that, he would just manipulate the multi-line string directly, and he would, like, if something was if he associated a number with a part, he would just like replace it with like dots and just like essentially just completely remove it from the string so that it won't matter when he like runs over it again, and all these kind of things. And of course, that's also a super valid approach, and it actually allows you to write a little bit shorter code rather than kind of recreating the whole data structure. But also looking at the code, at least for me, that's always just a tiny bit harder to follow because you're mutating kind of the entire data structure that you might be.
So I guess if you're in a small little processor inside a light switch, right?
Mm-hmm.
And you only have a certain amount of memory, or maybe you're like a little satellite flying somewhere. And for some other reason, you have to parse a map to figure out which part is missing, since we are in the sky with these elves now. Then it's not a question of being immutable, because you've only got one processor, you've only got one thread, and you only have a tiny little postage stamp of memory. And then the only way you could probably do it is by actually changing things in place to figure out.
I mean, if you go back and also look a lot at like the history of computing, if you look at how NES development or like Commodore 64 development is or was done. I mean, there's still enthusiasts doing this to this day. So a lot of like there's no immutability that you can afford. So you'll change registers and you'll keep track of your in your 64K of RAM and you'll move things around as you can to get the most out of the language. We do kind of, in this case at least, I personally like to indulge in the luxury of being able to create the slightly bigger data structures that allow me to just write code that I think, hopefully, if I were to reopen this again in 3 months, maybe my past self would speak to me through this code in a way where I can still understand the language.
So rambling passages of prose we write, and these people write single keystroke but flipping haikus.
Exactly. I also wanted to say the term that came to my mind was also haikus, which is great. I also have to say I'm very impressed that you say some of these things you can understand. The parts that I can understand is Control V and Escape. Like I'm not a Vim ninja by any means.
But those S/ are just doing search and replaces. The last 3 lines, there's some search and replaces. The S, I think, would do a search and replace, and those / are delimiting things. And I think the G on the end of the replace means like everywhere. And then the inside of those search and replacey things are like regexy vibes. I don't know exactly what the detail is there, but that's what those things are doing.
I guess, like Jonathan asks, maybe Vim's keystrokes are Turing complete. Who knows? But I think that's a great homework. If you're, if you've done all the challenges using Kotlin, you can move on to doing them in Vim keybinds. Maybe use the Vim emulator in one of our IDEs to attempt to build that. Who knows? Yeah. Wow. That was a lot of fun. I had a good time.
Yeah, me too. That was great.
Before we end, I once again have a small elf in the background telling me it's a good point once more to let you folks know that there are prizes to be won. Make sure you take a look at the Advent of Code blog post. It is not too late at all to enter this whole campaign, because we're not just rewarding people who hand in solutions the fastest or the quickest, or the longest or the shortest, but we also just want to we also want to reward community members who just take the opportunity in December to write a little bit of Kotlin, learn something new. So you can still enter and you still have the chance to win a couple of prizes. To see how exactly you get set up, make sure you go down to the prizes section. There's a couple of preconditions that you do need to fulfill so that we can reach you and so that we can find the code that you've written. And from there on, you're smooth sailing to the potential chance to get some exclusive Advent of Code in Kotlin swag, which hopefully is going to be exciting for you folks. Awesome. Well, Maya, thank you so much for coming on today. I do have a final question though, because it's not the first time you've done this. I'm sure it won't be the last. But in your intuition, what can we expect for the next couple of days?
Oh, definitely some 2D grids and more digits. Yeah, because he's already made us do regexes and checking digits. I suspect there might be some 3D things as well. And the other thing that's really quite interesting is I think this is the first year that the picture has got gaps in it and that there are not single lines. So go to what the picture looks like. Can you see 4 is slightly up? So I think we're going to have some spaces, the way we're floating through space and connecting the star dots. So I think we're going to get a really nice, interesting image in the end.
Do you think that's like the trebuchet, like bringing us into, like flinging us up further up into the stratosphere, and then maybe we'll take some kind of different mode of transportation somewhere?
We might. I think when you finish, the picture's going to look like star constellations in the sky. Yeah, where we went. So I think that's what's coming from the imagery side. And then towards the end, there's definitely going to be something that's going to eat my CPU. or eat my memory, heat up my computer, and even putting things with coroutines is not going to work. You'll have to just like figure out the right way to do it, because there's always that near the end.
I have to say, I find it very funny that you mentioned that, because that is 100% the same approach that I go through every year. There's some kind of challenge that requires you to find an algorithm with lower time complexity, and my initial thought is like, surely if I run this on 8 or 12 processors at the same time, surely I can beat out the algorithm. And then you do a little like back of the envelope like calculation, and you find out that it's still going to take like 2 years to terminate based on the progress that you're making.
So with the 8 cores, it would take 1.8 years.
Yeah,
but without them, it would take 2.
Yes. So unless I can briefly get my hands on a high performance like computing cluster somehow, probably we'll stick with finding a better algorithm. Yeah. Awesome. Great. Then thank you so much, Maya, for joining me today.
It was a great pleasure. I had a lot of fun.
And I also want to say thank you very much to everyone who decided that they would spend part of their Sunday with us and with puzzling around in Kotlin a little bit. I do hope that you enjoyed today's stream, and we of course also hope that you'll come back for a couple of the future ones, because as you know, we will be covering the first 12 days of Advent of Code in these streams, and we have a lot of cool guests that are still coming up. There's going to be a different guest every day, and everyone is going to have a different approach and a different perspective on how to solve the problems. And I think that's always really, really delightful to see. So make sure you tune back in, potentially tomorrow, where we'll have a really awesome guest who I think is going to show off a couple of very cool tricks of things maybe you can do in our IDE. We'll see what that looks like.
I've got a request.
Yes, please.
I hope there's going to be one on the notebooks.
I guess you'll just have to tune in to find out. But I think those stars might align. So yeah, please come back and have a look and see at all the cool things that we have to show you. We have for yourself. You obviously have tons of different ways of doing these kind of challenges yourself. Like Maya just said, you can do them in Kotlin notebooks. You could try out the Kotlin data frames library, or you could build visualizations in Compose, or you could do them in Fleet or in Android Studio or in just in IntelliJ. You can try parallelizing your stuff with coroutines. There's so many like different ways of how you can approach the problems. Whether you're just starting out and you're just getting your feet wet with Kotlin, or you're really honing your skills, or you just want to try something really crazy, like seeing if you could stack 3 build list builder functions into each other and seeing if that makes sense or is useful. I don't know. Give it a try. Everything's allowed in Advent of Code. And if you do submit your stuff, you have the chance to win some prizes. With that, I would like to say goodbye and thank you so much for tuning in. Hope to see you in one of the future ones. Take care, everybody. Bye-bye.
Bye.